In this video I'm looking at the solution to question 8 of the June 2011 Edexcel FP1 paper. The topic of the question is coordinate systems. The question starts by giving us the parabola equation y squared equals 48x, and tells us that the point P, which is given by 12t squared 24t, is a general point on this parabola. In part A we're asked to find the equation of the directrix of C, and then in part B to show that the tangent equation at the general point is given by x minus ty plus 12t squared is equal to 0. Finally, we're asked to talk about a specific tangent at the point 3, 12, and that meets the directrix at a point x. We're asked to find the coordinates of x. Well, the first part of the question, then, find the equation of the directrix. This is one where we just need the knowledge that y squared equals 48x. It comes from the general equation of a parabola y squared equals 4ax, and that means that a is equal to 12, and from your tables you can see that the equation of the directrix, so equation of directrix, is x equals minus a, so in this particular case it's x is equal to negative 12. The marking for that part of the question was a method mark for getting or seeing how to find a is equal to 12, and then an a mark, accuracy mark, for x is equal to negative 12. The second part of the question asks us to find the tangent. So standard procedure for finding the tangent is first of all to take the equation y squared is equal to 48x and to differentiate that to find dy by dx. Well, if y squared is equal to 48x, one way of doing this is to write y is equal to the square root of 48 multiplied by x to the power of half, and therefore dy by dx is equal to 1/2 of root 48 multiplied by x to the power negative 1/2. Or taking the half inside the square root, that becomes 4, so we get root 12 x to the power negative 1/2. We know at the point that x is equal to 12t squared, so substituting that into the value for dy by dx, we can see that that is equal to root 12, and then x to the power negative half is therefore 1 over square root of 12 and the square root of t squared, which is t. So the root 12s cancel out to give us 1 over t. Using that value of the gradient, then the equation of the tangent can be substituted into our standard equation for a straight line. So the equation of tangent, y minus y1, which in this case is 24t, is equal to the gradient 1 over t multiplied by the x minus x1, which is 12t squared. We need to multiply that throughout by y, so that ty minus 24t squared is equal to x minus 12t squared, and then rearrange that to give x minus ty plus 12t t squared is equal to 0, which is the form that we're asked to give the answer. The marking there was a method mark and a mark for getting the gradient, specific gradient, to be 1 over t, and then method mark for substituting the values that you know into the equation, straight line equation, and then an a mark for getting the final solution. And now, because this solution was given to you, this is what's called a correct solution only mark. In other words, any errors would lose that a mark. Just point out that there are different ways of doing the differentiation. You could differentiate implicitly, or also use the chain rule to find dy by dt or dx by dt. Whichever method you use, however, you will get the value of the gradient to be 1 over t. The final part of the question says that we have a tangent at a specific point now, 312, and that meets the directrix at a point x, and we're asked to find the coordinates of x. Well, starting off with the equation of the tangent that we found in the part B of the question, then and the fact that x is equal to 3 and y is equal to 12, well, from that we can see that the x equals 3 and 12x is also 12t squared, means that t is equal to 1/2. So therefore the tangent that we're talking about is x minus 1/2 y plus 3 is equal to 0. So it's just simply substituting the value at t equals 1/2 into the equation of the tangent that we found in part B. The directrix is at x equal to -12, and so substituting that into this tangent equation, -12 minus 1/2 y plus 3 equals 0, and that can be rearranged to show that y is equal to -18. So put those two things together, x has got coordinates -12 and -18. The marking for this part of the question, there was a b mark, so no method required for finding t is equal to 1/2. A method mark for using that value of t in the tangent equation, a method mark for using x equals -12 correctly, and finally an a mark for getting the coordinates of x correct. Well, that finishes the solution to this question. Solution to other questions for this module and indeed other modules can be found at www.furthermaths.org.uk.